Hello guys, welcome back to Maths on African Motives, still on our mathematics and six. Partial derivatives, the applications of partial derivatives. Partial derivative is actually a certain derivative that we had to consider. Not to say there are so many marks, but we just have to know the basics because it will affect us a lot if you do not understand the first question. So we are going to have this, which are the applications. What do you think of if you take, let's say we talked about this previously of a cylinder. Considering a cylinder, I mentioned about this before, having the radius and also the perpendicular height. Okay, considering this, we say the volume can be written as pi r squared h. This volume here that we see is affected by two things, the radius and the height at the same time. So you see that there can be a change that can happen in the volume because it is affected by two things. We can have the derivative of the volume with respect to the radius, like I said before. We can have the derivative of volume with respect to the height. These are the two variables that we have, the derivative of volume with respect to the height. Okay. If, let's say, we have these, and these are increments, changes, it can be a decrease, it can be an increase, which affects your volume at the end. So you will see that the volume also is going to change, okay? The volume is going to change. But its change now, which can be an increase, which can be a decrease, whatever change that can happen, it's a percentage, it's a what? It is going to be affected with the variables that you are given there. What are the variables? We have got radius. Remember, our volume is written in terms of radius and h. So we are going to have the derivative of the volume with respect to the radius, which is this one. So you're going to have the derivative of what you are given. You have to differentiate each and every variable that you're given. So it's going to be with respect to the radius times the increment or the increase or the decrease or the change in what is affected there, which is the radius. So you're going to multiply to the change in radius, which can be an increase, which can be a decrease. Okay? We add to another one again. Now we've got volume versus the height, which is this one. The derivative of the volume with respect to the height. Definitely what we're going to multiply with the change with respect to the height. Whether it's a plus, whether it's an increase, which is a plus, or a decrease, which is a minus, this one is the change that is happening to what has been differentiated with respect to the height, the change in height. Okay? So meaning to say, if we had, let's say, let us talk about a rectangular prism. We know that the volume of a rectangular prism is given by length, by breadth, by height. Remember that. Okay. This one, there are three variables here: the length, the breadth, the height. So the volume is going to be affected by all of these. They are not constants, they are variables. So it means the change that will happen in the volume is going to be affected by the derivative of the volume with respect to the length, right? Times the change that you are given in that length. Plus, we've got the volume with respect to the breadth. So it's going to be the derivative of the volume with respect to the breadth times the change in breadth. The same thing, the volume with respect to the height times the change in height that you are given, which is the depth or whatever that you have. So in actual sense, we are simply saying whatever change that can happen to a certain function, it must be taken from the given function that you have. If z is equal to, so you can conclude that if z is equal to f of x and y, whereby it's affected by x and y at the same time. All right. If this is what we are given in general, therefore, the change that can happen in z is going to be given as the derivative that you're going to have of z, right, with respect to x, which means f of x. So you need the derivative of f with respect to x, whatever that you're given there, okay, with respect to x. So you're going to have the derivative of z with respect to x times the change that will happen in x, plus the derivative that will happen of z with respect to y, in this case, times the change in the same y. That is what we have. All right. So this you can even write as df, like, because the f, z and f, they are the same. So you can write as f, you can write as z. It's one and the same thing. So this is where we have the applications of these partial derivatives, like these questions that we have here. We're given the question on the first part. There we have got the dimensions of a cone. All right. R is equal to, which is the radius. Remember, a cone is like this, shape of a cone. It's something of this nature, where we have got the radius and also the perpendicular height and also the slant height. All right, that's a cone. And we are also given the volume. If you're not given, then you have to know this. So the volume of a cone is the third pi r squared h, whereby we have the radius. We are given the radius. I want us to take the information here that we have. We have got the radius in this case, all right, given as 25 millimeters. Let me just write on top here. Radius equal to 25 millimeters. We are also given the height equal to 70 millimeters. Calculate the approximate increase. There is an increase there. There they've mentioned. Actually, they were supposed to say the approximate change. The change, we'll see it, whether it's an increase or a decrease. A plus, that's an increase. A minus, that's a decrease. So meaning to say, if we are to calculate this, our answer is supposed to be a positive, because already they mentioned it's an increase. So they cannot say it's an increase while the answer is a negative, right? So we need the approximate increase in the volume. So we are asked to calculate the change in volume, the change in volume of the cone. When the radius increases, now the radius is changing. Remember, I was talking about the change in radius, the change in this, the change that can be the increase, the decrease, the increment that is happened. So the radius, it increases. To increase, that's a plus. So the change in radius, that's 5 millimeters. And the height decreases by, it decreases. To decrease, that's a negative. So the change in height, that's a negative 10.5 millimeters. And the increase or decrease that is happening on the rate, on the approximate, it is taken, it's taken like meters per second, millimeters per second, the same as the volume per second. So this is actually supposed to be given as the change in radius, 5 millimeters per second, the change in height minus 10 millimeters per second, a change and decrease or increase. It's a rate. The rate of this is affected per unit time, per unit second. All right. So meaning to say that the unit, volume is going to be cubic meters. This is going to be cubic millimeters per second, because we're talking about the change of volume per unit time. So what is going to be the change in volume, whatever that you have now, you know this, we've got our information. What is going to be the change in volume? I said the change in whatever that you have is taken from the variables that are creating the formula for that. Our volume is given in terms of two variables, the radius and the height. We're given this is a third pi r squared h. It's given in terms of two variables, the radius and the height. So meaning to say the change in this volume is going to be the derivative of the volume with respect to the radius, the first thing, the volume with respect to the radius times the change in what you are differentiating with respect to. With respect to what? With respect to the radius. So it's going to be the change in radius plus the derivative of the volume with respect to the height. Every variable there has to be affected. You affect with respect to the radius, you affect with respect to the height. Every variable given there has to be affected. That is the condition of our question. So this is the derivative of the volume with respect to the height times the change that happened on that height. That's it. That's the idea. Only that you need the formula first. You are not given the formula. We are just given the hint on the formula for the volume. The rest, you are supposed to take it. Sometimes they give you this formula. Sometimes you're not. So you're supposed to take where it is given from. All right. That is how you create the formula. We talked about this. So what it means, we need the derivative of the volume with respect to the radius. The volume with respect to the radius from what we are given, which is a third pi r squared h, we are saying in this case is with respect to the radius. So what does it mean? H is a constant. Remember what I was saying about the partial derivatives. So once I need the derivative of the volume with respect to the radius, H is a constant at that moment. H is taken as a constant. Remember what we talked about before? So if H is a constant, it means a third pi and H, they represent the same thing. They are one and the same. It's a constant. It's a constant that because H is a constant already, a third is a constant, pi is a number. So they represent the same thing. So meaning to say, but a third pi H is a constant, this one. The whole part of that, the whole part that you see here is a constant. So what are you going to do? You're going to differentiate now with respect to the radius. To the radius, which is r squared. How do you differentiate r squared? You drop the exponent, that's 2, subtract 1. So it's going to be r to the exponent of 1, which is just what? Which is just 2r. So the derivative of r squared is going to give us 2r. So meaning to say we can combine this together. That's 2/3 times 2. I mean, a third times 2 is going to be 2/3. So this one is going to be 2 over 3 pi hr or pi rh, pi rh times the change in the radius. So you're going to just leave it like that. So this is the derivative of the volume with respect to the radius. All right. We do the same thing. This time we're going to have the derivative of the volume with respect to the height. So if we are dealing with respect to the height, what does it mean? This statement is going to change this time. The derivative of the volume with respect to the height, it means r is a constant this time. So r is the one that is now referred to as a constant. Remember our situation. So this part here is a constant, a third pi r squared, because we've got r there. It's a constant. The whole part of that is a constant. So a third pi r squared, this one, it's a constant here. It's a number, just like a number. So you differentiate h. What is the derivative of h? It's 1. Just take the number affecting h there, which is what? Which is 1. So meaning to say, the whole of this part was going to be 1 over 3 times this, which is going to be a third pi r squared. So that's a third pi r squared times 1. It's not going to affect anything. Times the change in the height. So we calculated our derivatives in this case from the volume, from the formula of the volume. We have to find the derivative of the volume with respect to the radius, after with respect to the height, but not forgetting your increments. So this is what we have on the change in volume, which is we just need to substitute whatever that you're given. We have differentiated everything. So we're just substituting. So this is going to be 2 over 3 times pi times the radius. We are given the radius as 25 millimeters times the change in the radius. So the change in the radius at that moment, it's a 5. So you have to consider what you are given in that case, right? So we have got R, then H. Before that, it's R here, which is 25, then H 70. Okay, sorry for that. Then the change in the radius, we said it's 5, and it's a positive. Remember, the radius, it increases. So if it is increasing, it's a positive. So that's times 5, like this. So this is a whole part together, combined, plus a third. So there we've got a third times pi times r squared. R, which is the radius, our radius is 25. So this is going to be 25 squared times the change and the height, which we said is a negative. That's negative 10,5. So we're going to multiply this to negative 10,5. So that's it. You combine everything together, you are supposed to obtain something like 48125 over 6 pi, like this. All right, of which if you write it as a decimal, that's 25198. All right, 25198,191 to 3 decimal places, and this will be cubic millimeters per second. Like I said, this is volume. The change in volume, it's going to be the units of volume per second, right? The rate of change. So that is how you play around with these typical questions. You need the whole of information. Consider the formula to be applied on that information that you are given. There will be a proper formula to be applied. Sometimes you are given this formula, sometimes you're not. So you need to take note of what you're given, the information that you're given there. All right, so if you consider the second question, we are given there even the formula. So that was an advantage. It is like this. A rectangular container, meaning to say we are dealing with a rectangular prism. Remember the dimension, the measure that we have. If you're dealing with a rectangular prism, we've got the length, we've got the breadth, and we've got the depth, which is the height. So that is what we have on our rectangular prism. So there we are given the information. Let us just take the information before we rush into answering this. A rectangular container with a length of 3,5. So we're given a length 3,5 meters, a breadth of 1,6 meters, a depth, that is the height. So the height is 0,8 meters. Remember, if you're saying 0,8 meters deep, that is the depth. 0,8 meters deep, you're going down. So it represents the height. Is expanding, take note, is expanding, to expand from our signs. It's an increase. Along its length, so the length is expanding by 0,04 meters per second, a change in length. So this is the change in length, 0,04 meters per second. Along its breadth, so this expansion, the expanding part, which is our expansion, is taking place to the length, to the breadth. So the breadth also is affected. It is an expansion, which is 0,035. Like I said, an expansion is a positive. So this is a positive, this is a positive. But if you take if you take this next statement, the container is contracting. To contract now, that is getting closer to like a decrease. To expand is like if I'm given something like this, then it is like this. Then contracting is vice versa now. So meaning to say it's a decrease, right? So a decrease in this case in terms of what? The depth, and our depth is the height. So the height is having the change of the height. It's a negative because it's contracting. So it's negative 0,05 meters per second. You have to be very, very careful on how you take your information, or how are you going to have your information here. But anyways, the question was to calculate the approximate change. This is what I was saying. This is the proper way of asking the question. Calculate the approximate change in what? In volume. It is you who is going to see the change. Is it an increase or a decrease? Like I said, an increase is a positive, a decrease is a negative. But yet it was an advantage. You're given the hint to calculate that change, if you check where are we taking this from, remember we're talking about the change in volume, and we understand that the volume of a rectangular prism is given as length times breadth times height. So that's where we see the derivative of the volume affecting the length. Like I said, it's going to affect the length times the change in length. Volume with the breadth, so it's the volume with the breadth times the change in breadth. Volume and height, this is volume and height times the change in height. So as you can see, that is where the formula was taken from, right? We have our formula for volume. So here, it was not going to be an effect. We just need to find the derivatives, then we answer our question. So the change in volume is going to be given as what? Let us start. The derivative of the length of the volume with respect to length. Remember, our volume is given as LBH. What will be the derivative in this case of the volume with respect to the length? With respect to the length, it means that the breadth and the height, which is the depth, they are constants. Remember, what you're differentiating is length. So the breadth and the height are constants. So if I differentiate L, what do I get? That's a 1. So 1 times BH, this is going to be BH. So that's BH times the change in length. All right, plus the derivative of volume with respect to the breadth. It is the same thing, just like the previous case. With respect to breadth, it means the length and the height this time are our constants. The length and the height this time, these are the constants. Then you differentiate with respect to B. If you differentiate B, what do you get, guys? That's a 1. It's just a like X. The derivative of X is 1. So it's going to be L times H times 1, which is LH. So this will give us LH times the change in the breadth. So we're going to have the change in the breadth, all right? Plus the volume to the respect to the height. What is going to be the derivative of the volume with respect to the height? It means L and B are constants. So the derivative of volume with respect to the height, L and B are now constants. So if I differentiate H, I get what? A 1. So this will be LB. So we're going to have length times breadth times the change in the height that you are given, like that. Okay, so this is it. This is it, like that. Okay. Now this is what you're going to have. From this part, we are going to substitute every information into the formula. So the change in volume is going to be the breadth times the height. The breadth, because everything is there. The breadth, we have it. Our breadth is 1,6. So that's 1,6 times the height. Our height here, which is 0,8. So that's 0,8 times the change in length. Don't forget that the change in length, which is here, the change in length is 0,04. And it's a positive. Remember, it was expanding. So it's a positive 0,04, like that. Combine this. Okay, we move on to the other one, plus, gonna move on to the second one, the length times the height. So this is what we have, the length, 3,5. So it's going to be 3,5 times the height. Our height in this case is 0,8 from what you're given here. 0,8 times the change in the breadth. The change in the breadth, it's a positive, which is 0,035, like this. All right, plus we move on the length times the breadth. So you're going to have the product of the length to the breadth. 3,5 times the breadth, 1,6 times the change in the height. The change in the height, which is negative 0,05. So that's it. We have to combine everything that we are given. We have to combine everything that we are given. That is it. Gonna have the change in the volume in this case, and that was going to give us a negative. That's negative 0,1308, something like that, which is, like I said, it's volume. So volume, the units for volume, cubic meters. Since this is meters, so volume will be cubic meters per second. So that's what you're going to have at the change in volume, which is actually a decrease, it is contracting. All right, it is getting together. It is contracting at that moment. Expansion, it's a positive. That's an increase, but a negative, a decrease. So that's how exactly you are supposed to expect to be asked these questions. All right, the length of the base, we are given the length of the base of a right angle triangle on another question here is 3 meters. So we have a right angle triangle, right? Remember, so we're given the base, which is the length of the base. So let's say this is the base, this is the perpendicular height, right? So they were given the length of that base, which is our base, being 3 meters, and the perpendicular height, which is the one that meets at 90 degrees, is equal to 5 meters. In constructing the triangle, an error of, so the error, the increase, the percentage error or whatever, it's the change, what is happening. So they're saying there was an error of 0.1 meters made with the base. So the base was affected by 0.1 meters, all right, which is the base. And an error of negative 0, in the perpendicular height. So this height here was affected by an error of negative 0.13 meters. And you're given also the side. So this is your width. Use partial differentiation to determine the error made with the area calculation. Not volume. This is a plane shape. Remember, we're talking about a plane shape. That is in terms of area. And so you need the formula. What is the formula for area? That is first thing. Because you're given a right angle triangle. And what is the area of a right angle triangle? It's half base times perpendicular. So as you can see, our area is affected by two things, the base and also the height. So due to these errors, it is going to affect even our area. So the change in area is going to be the derivative of area to the breadth. So it's going to be area with respect to the breadth times the change in the breadth. All right, what is being affected, plus area with respect to the height, the derivative of area with respect to the height times what is affected at that moment, which is the height. That is the idea there. So simply we need these derivatives, all right? So that means the change in A is going to be the derivative of A with respect to B, area. With respect to B, it means at that moment, guys, H is a constant, all right? Remember, we talked about this. So half H is a constant. We differentiate B. What is the derivative of B? This is 1B, so it's going to be a 1. So meaning to say, we're going to have half H times 1, which is half H, all right, times the change in the breadth plus the derivative of area with respect to H. So it means B, it's a constant. So you're going to have half B as a constant times the derivative of H. What do you obtain if you differentiate H? It's a 1. So this will be half B times the change in the height that you're given, which is the depth. So with this information, you can be able to calculate the change in area or the error that happened in area, since we just have to calculate, simplify everything by substituting the height, 5 meters, times the change in the breadth. All right, this is B, guys. This one, B, not H here, B. This is B. The change in the breadth. Remember, that's a B there. The change in the breadth, which is 0.1. All right, plus half times the breadth, which is 3, times the change in the height. Remember, our height is negative 0.13 like this. So that's the change in area. So the increment or the decrease or whatever that happened is affected from this part that we have, and that was going to give us 0.055 square centimeter. So that was the change in area when there is an error of what? Of 0.1 made with the base and also negative 0.13 made with the perpendicular height. The error for the error affecting the area was going to be given as 0.055 square meters. So shall see more questions to come on this typical topic, and also question number 1 and other questions from Mason African motifs.